fun to do?
I know something fun that we can do.
Like what?
Learn physics.
Teach me some physics stuff.
Well, the first thing you need to know is some basic vocab. Let's start with mass. Mass is the amount of stuff in an object. Do you get that?
Kind of.
Okay, let's put it this way. Are these your Legos?
Yeah.
Okay. The bigger one has more Lego pieces in it, or stuff. So that means it has more mass than the smaller one, which just has less Lego pieces. Do you get that?
Oh, okay, I get math now.
Alright, let's talk about acceleration now.
Okay.
An acceleration is how fast an object speeds up or slows down, or an object's change in motion. Maybe I'm not explaining this right. Let's just use a rocket as an example.
A rocket?
Yeah, when a rocket lifts off, it starts moving very slowly, but as it continues to go into the sky, it gets faster and faster. This means that it's accelerating.
Yeah, I know what you're talking about.
Eddie, do you know what force is?
No clue.
I thought so. Basically, a force is a push or a pull on an object.
Could you elaborate?
See that book over there? Let's go look at it. Come on, Eddie. Eddie, over here. Right here. This book. So basically, there are forces acting on the book right now.
Really?
Yeah. Actually, there are forces pushing and pulling the book. Here. Here. And here.
Interesting.
Let's go back to the book on the table. It may not look like there are any forces acting on it, but that's just because they're equal except in opposite directions.
So it's like they cancel each other out?
Exactly. This idea of equal forces is known as equilibrium. There are two types of equilibrium, static and kinetic.
What kind of equilibrium is this?
That's static because it's not moving. So try to guess what kinetic equilibrium is.
Equal forces when an object is moving.
You got it. Now that you got the vocab down, let's go into Newton's laws of motion. Here's the first law. Basically it says that an object will continue to stay in the kind of motion that it's already in unless another force does something to change it.
I'm not getting this.
Come on, Eddie. Let's use this ball as an example. That an object will keep moving unless a force acts on it. Like this ball. My foot was the force that stopped the ball from moving. If I hadn't stopped it with my foot, it would have kept going. Now that it's resting, my foot being the force could move it again, changing its direction. Newton's first law. Now it's time for Newton's second law. In a nutshell, it means force equals mass times acceleration.
What?
Tom, I think it's time for the chalkboard. I think you're right. Okay. Force equals mass times acceleration. We already talked about what all these three things are, so you're familiar with them. Basically what this means is, the more stuff something has, the bigger it is, and the higher rate of motion that something has, the bigger the push or pull on an object is going to be. So, force equals, if it has a tiny mass and a big acceleration, then that means it's going to have the same force as something with a big mass and a tiny acceleration.
Oh, I got it. So force equals mass times acceleration, right?
Yes, sir. This little ball, if I roll it like this, will have the same force as this big ball if I roll it like this. Now let's learn Newton's third and final law of motion. It says that every force has an equal but opposite reaction force.
Is there a clever way I can remember this?
Sure. Just remember, forces are like shoes. They come in pairs. Okay, for special forces, I'm going to bring in DJ to teach you.
Okay.
First force we're going to talk about is weight.
I kind of know about one.
Do you know it's caused by the force of gravity?
I did not.
Well, the force of gravity depends on the mass of an object because Earth's gravity is always the same.
Which means?
It means the more mass an object has, the more it weighs.
Here's a force that you might have trouble understanding. It's called normal force.
Normal force?
Yeah, it kind of works against the force of gravity.
How so?
Let's go back. Alright, Eddie. Remember how I told you about Newton's third law and how forces come in pairs?
Mm-hmm.
Alright, well, on this book right now, there are actually two forces going on. The first force is gravity, which is causing the book to push down on the table. But the second force, which makes up the pair, is normal force, which is the table actually pushing up on the book.
So the table's making a force on its own?
Yep, normal force.
Okay, Eddie, I'm going to use guitar to explain this force.
What's the force?
It's called tension. Tension is basically force caused by the pull on a string.
Like the strings on in the guitar?
Exactly. The more I pull on these, the tighter the strings get, and the more force is applied on the ends of the strings, all because of tension.
Do you ever wonder what pushes the ball off the wall back to us?
It's Newton's third law.
What?
We taught him pretty well.
He's smarter than most of them.
Tom's chasing me.